In this video, I want to introduce you to the R programming language. So eventually we're going to start looking at the language itself. Now there's no ways in a short video I can really introduce you to the whole of the programming language, but I'm going to show you the essentials, specifically those things targeted towards what we ultimately are aiming for, and that's to write code that will do some deep learning for us. So once again, this document is available on RPubs. I'm going to put it out on GitHub as well. You can download this and install it. A couple of things that we are going to go through. You can see here that there is an interesting history to R, and you can read some of that right there on Wikipedia. You've also got to download and install R. And if we move down here, you'll note that there, and I'll put these links down below, there is a link here to how to download R for your specific programming environment, for your operating system. So that would be for Windows, for Mac OS, and for Linux. You can find all the downloads and install instructions there. It is simply downloading a file and running that file, and it'll install. Now there's a beautiful program called R Studio, and you see the link there. You must also download and install that. That creates an environment, a program in which we're going to write the code, and it's an absolutely phenomenal coding environment. And whether you are new to R or whether you are an expert, it just makes the writing of code such a pleasure. And it allows for the creation of much richer objects than just code. You can write a book, you can write documents, dissertations, you can create websites, you can create applications. There's just no end to its capability. So I really want you to install R Studio as well. It's simply following those two links. As I said, I'll link to that in the description to the video down below, and also where to download all these files. Both viewing them on RPubs, this document, which was created in R Studio, by the way, as all of these documents are, and to the files themselves on GitHub. So without further ado, let's get into a bit of the language. Well, at least first the R Studio coding environment. As all the knocking and banging outside my office where the construction of the new neuroscience unit has been done. It really is an earful, so apologies for that. Let's get started. Once you've installed R and then R Studio, you can open R Studio, and this is what it looks like. Now I've installed R version 3.5.1, the newest version as of the time of this recording. You see its code name there is Feather Spray, and installed it for 64-bit Windows system, and here we have it. It should be rather familiar to anyone who's opened a spreadsheet file before, or a file or a word processing file such as Microsoft Word, etc. And we have this menu system up above. There's the normal file, and you can do new file and save as. You can edit a few things that you might not see in usual programs: plots, sessions, build, debug, profile, tools. Tools is quite important because you can go down here to global options, and you can set quite a few options. For instance, here in appearance, you have some themes. The default here is Crimson Editor, Dawn, Dracula, Dreamweaver. You can really set your coding environment to look the way that you want, and I've increased the font size here to 16, so it's easier for us to have a look at in this recording. Now there are basically 4 panels. You can only see 3 at the moment, but there are 4, 1, 2, 3 here. The 4th one is as we create a new file. So this panel here is actually the bottom left panel. It has a console, and a console is very simple. You can just type lines of code here, 2 plus 2, and I'm going to hit enter, and we see the solution there, 4. And there's a new line indicated there. The 1 here indicates that there's only one element in the solution. If there were more, they'd each have an address starting at 1, the first element, the second, the third. That's what that 1 refers to. When it runs over multiple lines, my answer, the first element in a new line, it'll have its number here in square brackets. As simple as that. We also have a terminal here, which is very similar to a terminal that you might find in Mac OS or in Linux. What you might find in Windows as well. In Windows we call it the command prompt, of course. So that's very similar, and you can interact with your computer if you know how to use that kind of code. Let's go back to the console. On the upper right, there's 3 tabs usually. The environment, and we'll see what happens as we start writing code. The history of code that has gone before, and connections we're not really going to deal with in this video series. On the bottom right, we have the files, which just shows the files in your current structure, and you can also navigate as you would in your normal explorer of your folder structure, your file structure on your computer. Plots, if we've created any plots very nicely, you can export these plots as PNGs, as PDFs. Packages is very important. As you read some of the history of R on Wikipedia, you might notice that there is this base or core R that can do a lot of statistical functions, but there are countless other libraries or packages that you can import that others have written. It's all open source. You can just install them. Click on it and install it, or hit install and then type the name of the package. It'll ask you what the default library is, and that is we are in 3.5. Some packages make use of other packages. Those are called dependencies, so just have that clicked as well. So those are also installed. So click the name of something for instance like Plotly, which is a plotting library. We see it comes up there, and you can simply install it now. It's available. It's extended the functionality of R, and there are so many of these. There's a fantastic help system. You can just type in the name of a function, and we're going to talk about what functions are. For instance, if you want to calculate the average or mean, the keyword function is mean. I can type in a mean, and we can search for that. Let's search, type it in the correct bar, in the correct space, of course, mean, there we go. Let's search for mean, there we go, that looks better. The arithmetic mean, how to use it, tells you what arguments are, and we'll go through, what these things are very shortly. But a fantastic help system. Just type in what you're looking for, and you'll get some help on that. The RStudio website is also a fantastic resource just to look for help. Viewer is something I'll show you if we create documents or dissertations or books, or whatever. The viewer can display that for us. So let's just jump into creating a new file, and there we'll simply see this little down arrow there for new. We could also go file, new file, and we see our script, our markdown, and our notebook, our markdown. Shiny is a web applications. You can code in other languages, create text files, presentations, documents, HTML files. So much you can do. Now we're going to create a new script. All the documents that you see on RPub for the series though are created in Markdown, and we'll have a quick look at Markdown as well. But let's just create an R script, and that's going to open up this top left panel here, which was hidden. As you can see, there's the console and terminal now on the bottom left. So here we just write lines of code. So let's start with something very simple, and that's just a comment. And the comments are preceded by a hashtag, and I'm just going to say this is a comment. And if you want to leave comments for yourself as you write code, just leave comments. Anything in that line after this hashtag is just totally ignored. Now we see a number 1 there. That's our first line of code, and to execute that line of code, as long as I'm anywhere in this line, I can just hit the run, and that will execute that line of code. Now it's totally ignored by R because it is preceded by this hashtag. So I can just hit enter and move down a little bit, create myself some space. So let's leave ourselves a comment that we're going to write some simple arithmetic, if I can spell that, arithmetic in this section. So there we go, simple arithmetic, and let's do the 2 plus 2 again. I like to use spaces. You don't have to use spaces. So I've got 2 plus 2 there. I'm going to click run, and there we have exact same thing down in the console here. We see the 4, and there's only one element there, so we see the 4. So you can try anything else. Let's try some trigonometric function. Let's ask for the sine of pi, the sine function, and we want pi over 2. So that's 90 degrees, pi being 180 degrees, pi radians. And I executed it this time by just holding down the control or command key if you're in a Mac, control for PC and Windows, and hitting the enter key. And instead of being in that line and running, I can do the same thing holding down control or command and enter. And we see the pi of 90 degrees, or the sine of the pi over 2 or 90 degrees is just 1. So there's so many. Let's do 2 minus 2. I'm holding down control, hitting enter, and I see that is 0. So really try some of these. And in the help section here, if we go there, let's just see what the cosine function would do. And it tells me there, shows me the other trigonometric functions there, and you just do that. Now a function is, after a function you see these parentheses, and then you pass something to the function. And this something that is called an argument. You always pass an argument when you call a function. Calling a function means writing it and then hitting Control Enter or return, Control Enter or Command Return on a Mac, and then you get this solution. That's when you call a function, but you have to pass, to most functions at least, you pass an argument. And then in the details here it'll tell you, it says there the arguments, you can pass 2 arguments, numeric or complex vectors, and we'll get to what vectors are in a little bit. So there are so many of these inbuilt functions in trigonometric, transcendental, so many built-in functions for arithmetic, and I really want you to play around with those. The next thing I want to just talk to you about is an object. Also we can also refer to this as a computer variable or computer variable name. So I've written something there, 2 plus 2, but I might want to store that value for later use so that I don't have to write that in all the time. Let's create a computer variable, and you can use any word. Try to use words that are descriptive, so when you refer back to this later in your code, that you know what is stored inside of that object. Now an object really is just the space that is created in your computer's memory, in which that object is stored, and that object has a type depending on what kind of data it holds. So let's create this computer variable, and I'm just going to call it something like my text. As I said, there's some restrictions on this, so don't use words that are already built into, don't use sign, for instance, the SIN as a computer variable or object name that already exists, so don't overwrite that, and don't use illegal characters such as spaces. Now, there are some conventions that some people stick to. This is camel case. In other words, there are 2 words there, my and text. There's no space between them. The first letter is lowercase, but each subsequent word starts with an uppercase. So that's one way of going about it. Some people use snake case. That'll look something like this, where the words are strung together with underscores. Another popular way is just to put dots in between. So my dot text. So let's do that. And now instead of using an equal sign, which you can, but let's just use the convention, which is this symbol. I'm going to hold down Alt on a Windows or PC or Linux, hold down the Alt and hit the minus sign. And you see this less than and minus sign come up. That is equal to an equal sign. Let's put it that. It's an assignment operator. I'm assigning something to this object called my text. And since I've called it my text, let's pass some text. Text is always passed inside of quotation marks. And I'm going to say this is text. I'm going to hold down Control and hit Enter or Command and Return. And I now have my text. Look what happened on the right hand side here. Under the Elements tab, under values, there is a new variable called my.text and what is held inside of that. So you get this list of all the things that you've created and what the value is that's held inside of this object. And just remember, everything has a type. So the type of the content in this object is a string. A string because it's inside of quotation marks. Let's create another one. I'm going to call this one my answer. So I'm using camel case in this instance, holding down Alt and minus or Option and minus. And I'm going to store in that my answer is the solution to 2 plus 2. Control Enter, Command Return, and we see my answer is now there, and it's 4. And later on in my program, I can just use my answer. And as I type it, a tip even comes up, and it says, well, MYA, there's something that already exists, so I can just hit Tab and it'll auto-complete for me. If I now hit Control and Enter, Command and Return, we see the solution pop up here in the bottom. The my answer, it holds the value 4, and the 4 is printed there. So that 4 is always stored inside of my answer, and I can reuse that all the time. That makes it very, very useful. So let's move on to something called a list. So let's do this. Let's do that. There we go. Let's do lists. And a list is just something that is more than a single element, although in R, even a single value like 4 is actually also a list. And R refers to these as vectors. Everything is stored inside a vector, which is just a list of elements. And a single value, of course, is also a list, a vector. And if it's a list of integers, it's a numerical vector. And if it's a list of text, it's a text vector. And that's just the term that is used. So let's create one. And I'm going to call this one temperature. Temperature, I'm going to hold down Alt and minus, Option and minus to have this assignment operator. And the way that we put lots of elements together is to group them inside of a vector. We separate them by commas, but we use a function called C. I suppose for we concatenating something, we're putting something together, C. So let's have some temperatures here. Let's have a temperature of 72 and 69 and another 72 and a 70, 70. And there's 4 numbers. Let's make it a more balmy 85. I'm going to hold down Control and Enter, or Command and Return. And now we see temperature saved up there. Now look at it. It says it's a numerical vector and it has 5 elements. So these are the addresses 1. The colon means through, 1 through 5. So there's number 1, there's number 2, there's number 3, there's number 4, there's number 5. So that is a list. I just want to show you another quick way to do this. Let's create another one. I'm going to call this one my list using camel case. And I'm going to assign that a sequence. I can create a sequence of value with a SEQ. And you see SEQ comes up there. There's actually a little tooltip there. And it says if you hit the F1 key, let's do that. The help actually opens up and it gives you the sequence there and how to use the usage, the arguments that can be passed, some more details. So all the help for sequence. Now, the simple way to use sequence is to state a start number. So I'm going to say start at 1. Stop at 10 and go up in steps of 1. Let's execute that and we see what we have here is a my list. It's numbers. There are 10 places and it is the numbers 1 through 10. I started at 1, I ended at 10 and I went up in steps of 1. So to create sequences can be quite helpful. If you want to know how many elements there are in that, just simply use the length function. So I'm going to say what is the length of my list? And very quickly it's going to tell me it has 10 elements in there. It just counts how many there are. So that's quite useful. The next thing I want to talk to you about is just some for loops. Let's do that. Let's do for loops, for loops. Now that is how you iterate through something. I'm going to iterate through a piece of code over and over again, but I'm going to control how this iteration works. So let's create a variable. I'm going to call it my numbers. Computer variable and object, assignment operator. I'm going to use a sequence. And the sequence starts at 1, ends at 10, and it's go up in steps of 1. Let's do that. So I have my numbers now, very similar, of course, to the my list that we just created above, but I'm going to do that. Let's create something that holds a 0, and I'm going to call that sum.total. And in sum.total, I'm going to store the value 0. Hold down Control, hit Enter, or Command and Return on a Mac. And now we have this sum total. Now I'm going to create this for loop. And the keyword is for. And I type in for. And then I'm going to put in parentheses what I want to happen. I'm going to use a placeholder. You can use any placeholder. Many people use I. Let's use I now. So for I in my dot numbers. And you see the little tooltip coming up. I'm just going to hit tab for auto completion. So what does this say? It's actually, it's actually very close to just normal English. It's saying for I in my numbers. And you can see my numbers is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can well imagine for I in my numbers means, well, first take the 1, then the next one which is a 2, then the next one which is a 3. Just go through each of the elements that are held in the numerical vector called my numbers. We're just going to iterate through that. And then after that, what I want to happen during each of these loops must go inside of curly braces. So I put my curly braces there, and whatever has to happen happens inside of these curly braces. Now it's useful just to hit Enter or Return here, and you see there's this automatic spacing that happens that last, when I was between those two braces, the last one went to the bottom, and there's this bit of padding there. It's just looks nice on the screen, and that's something that RStudio is doing for you right here. So what do we want to do? Well, what we want to do is take SumTotal. So I'm going to take SumTotal. Remember, at the moment that is 0. And now I'm going to use the equal sign. And it's going to look weird the first time that you see this. I'm going to say sum.total, again, plus I. Now that doesn't look like very good mathematical algebra there, and certainly most computer languages don't work like algebra. What it does when it sees an equal sign or an assignment operator, and as I say, normally we use this assignment operator, but inside of these loops we'll use equal. It says whatever's on the right hand side, execute that first and then place it inside of what is on the left. So what is in SumTotal at the moment? At the moment, SumTotal is an object and it holds a value 0. And I is at the moment is the first element in my numbers, which is 1. So it's 0 plus 1, and that is 1. And this 1 now gets passed to SumTotal, and it gets that piece of memory, that memory in your computer gets overwritten where it had the 0 in it before. Now it holds the value 1. So it's going to go through the second time. Now remember, I moves to the next element, which is 2. SumTotal still has the value 1 in it. I is now 2. 1 plus 2 is 3. 3 is now passed to SumTotal, which now holds the value 3. And we go through each of these. So let's run that. And let's call SumTotal. Sum.total. And see if I take the numbers 1 through 10 and I add all of them together, what am I going to get? Well, I get 55. We can see the 55 here at the bottom, and we can see SumTotal has been updated here on the top to 55. So that is very convenient just to run through some code, just doing something over and over again, and then extracting some useful information from that. Let's move on to functions. And we're going to use what we've just done now inside of functions. Now we've seen a little bit of functions before. We've seen what the sign function looks like, and we know that it's built into R, and we have parentheses around that when we pass an argument to that. Say for instance I just want to calculate the average of the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a built-in function called mean, and I'm just going to pass my.numbers as an argument to the mean function, and we see at the bottom it's 5.5. So the mean of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 5.5. Now, this one's going to be a bit difficult. I want you just to concentrate now, and I want to show you something very beautiful actually, in that we can create our very own functions. So I'm going to call my function my.mean, just to be different from the inbuilt mean function. So I'm going to give it my.mean. It's an object, I give it a name. But I want to tell R that this is not a normal object, that this is actually a function. So I'm going to use my assignment operator, and I'm going to use the function keyword just to tell R that my mean is not a normal object, it's actually a function. And remember, a function has arguments passed to it. Doesn't always have to be. There are some functions that don't have arguments. You still use the parentheses though. But I'm going to put just a placeholder in there, and I'm going to call it vals, so I can refer to vals, some value that I'm going to pass to my function. So the argument has the placeholder name vals. So in mean we passed, remember, SumTotal as an argument. The same here with vals, but it's just a placeholder. So I've got this function, and again what happens to it must go inside of curly braces. So in between my two curly braces, the second one was automatically put there when I opened the first one. I hit return or enter so that it makes a new line, and it all looks very nice and neat. So what I want to do inside of this, I want to recreate the mean function. Remember, the mean adds all the values and divides by how many there are. So I'm going to create a computer variable called number.of.elements. It's a descriptive one. I understand what it means. So I'm going to assign to that, I'm going to assign the length of whatever the argument was that is passed. Remember, length just tells me how many elements there are in what I pass. So that's one. I want to create another one called cumulative.total, and I'm going to initialize it with the value 0. The next thing I want my function to do is go through a for loop. So I'm going to say for I in vals, and that's exactly what we did up before. So it's just going to iterate through everything that I pass to this. Again, what happens goes inside of my curly braces. What I wanted to do is to say cumulative.total equals cumulative.total plus I. So exactly the same as we did with the for loop before. So whatever I pass to my function, my mean, it's just going to iterate through all of them, and it's going to sum all of them up. The first one plus the second one plus the third one, exactly as before. So now I want to go outside of my set of curly braces for my for loop, because that's all I want my for loop to do. Now I'm back in the curly braces of my function. And what I wanted to do is to return something. So return is a keyword, and whatever is inside of these parentheses, it returns. And what I want to return to it is the sum total divided by how many there are. So it's cumulative.total divided by number of elements. Number of elements. That's what I wanted to return. And I'm going to just go outside of that curly braces, hit enter, control and enter, command and return, and I now have a new function, and we see it appear there, my.mean, and that is a function. Let's test it out. So I'm going to say my.mean, I'm going to call that, and I'm going to pass that my numbers to it. The my.numbers that we created, the 1 through 10, remember, I'm going to pass that, and I see my solution again is 5.5, just as the inbuilt mean function was. So pause a bit, look through this function again. It really is plain English. It tells you what it's trying to achieve, and it's very expressive. Now these things that I create inside of the function, they are these local variables, and something that I create outside of a function, those are global variables. I'm not going to go into that, but you can read up. That exists for many computer languages. But it should be quite simple to figure out what is happening here. I've created a function called my.mean. It takes an argument which I can pass to it, and in this instance I passed my numbers to it. What I want to do is to have two things: sum up all those values that is passed as this argument. I want to know how many there are so that I can return this total divided by how many there are, which is the equation for arithmetic mean. And to do that, I went through this. Well, there is an inbuilt function, of course, in R that can do this for you, but I used this for loop inside just to go through each of these and just add them. So you can create your very own functions. The next thing I want to show you is just how to load a data set. Now, how to do that, I'm going to actually open the source document that I created for our pubs, and that is on GitHub. So this looks very different. This, you see it's a tab there. This is the script file we've created, and we can save that. On this side, we have an R markdown file. So when I said file new, this was not a script, but a markdown file. And a markdown file is like HTML that you would know in a website. So you still see the lines of code here on the left-hand side. It starts off with something. Now this will be created automatically. This is YAML, Y-A-M-L, just another markup language. A markup language is just well, in some sense you can see it as a subset of the full set of HTML code, which is used in websites, the language for websites. So it sets out a title and an author, and then output. I want this to be outputted as an HTML document, a table of content to be set to true, and that's where you see that table of content on my rpubs files, and I don't want the sections numbered. And now what happens is you can write normal paragraphs and create all sorts of nice things, but the R code itself has to go inside of these three ticks. So that's on the top left of my keyboard, next to the 1 key. There's 1, 2, 3 of them, which indicates we're starting the R code, and 1, 2, 3 ticks, we've ended it. Now this is some automatic setup for this page, don't worry about that. I've also included some style, a cascading style sheet here. Don't worry about any of that. I'm just saying colorize my large headings with this color, my second largest headings with this color, my third largest headings with that color. Just creates a bit of color in my documents. You see the orangey gold and the blue that I always use. This is my PNG file, which is the logo, and this is how I get that to be expressed. 2 hashtags here, those not comments, this is outside of the code. That just says heading number 2, so that gives me a fairly large heading, and that heading is introduction, and then I start writing normal paragraphs, normal English paragraphs. I write all of that. And if I want something to look like code, but it's not really code, I put that inside of these single little tick marks. Write more normal code, write more normal code, and here 2 hashtags, that is markup language, and it says do heading number 2 again, so that's larger, normal text, heading, normal text, heading, etc, etc, etc. I want these to appear as code. They're not executed, just as code, so they go inside of those single ones. You see these 2 dollar signs here. Whatever I put inside of these 2 dollar signs is called LaTeX. And LaTeX is a way to write mathematical expressions. And you see there the Euler's number e to the power 1. You see how that is created. Single little underscores before and after word changes that word into italics. So that will be printed in italics. If I put 2 of those, that will change to bold. So I open and close a word or a sentence or some piece of part of a sentence in these, and that becomes italic. And you can see it goes on, and here I want to execute some text, so those goes inside of 3 of these little ticks, and it actually has something here on the right hand side. I can actually run that content. It's called a chunk. This piece of code is called a chunk, so that will be the code that you write as we wrote here in the script file. That is something that we write here, and it's called a chunk. And I do that with just telling it that we are writing in R, because you can specify other things inside of these set of curly braces. It says R code is about to follow, and we close that R code. And that's how we go about it. So I just want to go down to the section I want to get to. There was the section on the for loops, and you see the code written there. I can execute that code by just hitting that run, that current chunk. And we see the functions bit coming up there. And there we are with loading the data. Now when I create a file, I can save the file somewhere on my hard drive. Now this document's already saved. You see the little save icon there is blanked out. It's saved at the moment. If I change anything, that'll light up again so I can save the changes. So I like to save these on my hard drive somewhere. And if I want to import a spreadsheet file that contains some data, if I want to work on some saved data inside of a spreadsheet file, I want to import that file. What I usually do is I save both this file and that spreadsheet file containing the data inside of the same folder on my computer's hard drive or solid state drive, so that they're both in the same. And I can use this get working directory function. If I write that line of code, it'll tell me the address to on my hard drive or my solid state drive where this file is saved. But I can also set a working directory. So I'm saying set working directory to the get working directory. So it's going to go out and see where is this current file saved, and then pass that to set working directory, so that this document says when I look for files, I'm going to look inside of this directory where, or folder, where this R document is saved anyway. So that if I want to refer to a file, I can just simply refer to that file. Here we have logisticregression.csv, a comma separated value spreadsheet file. And I don't have to type the whole address to it. So on Windows that would be C:// blah blah blah, and of course on Mac that will be different. But I don't have to refer to that because I've set the working directory to the current working directory where this file is saved, and I know I've saved logistic regression in the same folder or directory that this markdown file is saved in. So I don't have to refer to that long address. And to import a spreadsheet file, I use the read.csv. This is a CSV file. So I'm going to call the function read.csv, pass this as an argument inside of quotation marks, and I'm going to pass that to this object that I'm conveniently calling data. So let's set this working directory first by running that line of code. And you saw the little green there as that got executed. And now we're going to import that line of code. And run that line of code, so data is now imported. And if I look up here, I see there's new data. So that was values. We had functions before, but now on the top here we have data. And if I click on this little square on this side, it's actually going to open something on a tab here. It's very small to see, but there you can actually see the spreadsheet file. Beautiful. And that's why I say this is such a lovely coding environment, and then I can actually play around with this, filter some of the data. Beautiful environment here. But let's get back to my file. So that's imported in data now. I can also call the view function with an uppercase V that will do exactly the same as clicking on that little square at the top there. Let's just close down this bottom left. And that is how you import data, and that data is now ready to be used, and we're certainly going to use data in this way when we do create our deep learning or our deep neural networks. Now we're going to use Tensorflow in this course. Tensorflow, of course, is Google's open source framework for tensor calculations. Those are the calculations and the framework we need to create and run our deep neural networks. And we're also going to install Keras. Now Keras just sits on top of TensorFlow. It can also sit on top of other frameworks, but we're going to use Google's TensorFlow. And it just makes writing code a lot easier. It's much simpler code. It looks like R. It's very easy to do. So you don't have to do the laborious coding that is sometimes involved with TensorFlow. There are new versions of TensorFlow coming out, which is going to make the writing of code slightly easier. But Keras has become so popular that it's even built into versions 1.9 and up of TensorFlow. So you write a simple line of code, it recreates that in more complex TensorFlow code behind the scenes so that you don't have to write that complex code. But it's the same thing. It's still going to be TensorFlow code. So to install TensorFlow, I want you to install two packages first. One is called Reticulate. So you can come here to Packages, hit Install, type Reticulate and install it. And the second one is called DevTools, DVTOLS. And you're going to do that in exactly the same way. Now, if you're on a Windows machine, you also have to install RTools, as you can see there, RTools, and click on that link, which is in the document. I'll link to it as well. So on Windows, you have to install that RTools for DevTools to work. So install DevTools and Reticulate. On Windows, also install this RTools. The RTools you have to do from the website. With DevTools and Reticulate, you can do that right here. And then we're going to install TensorFlow and Keras. Now to install these, simply follow this link. Once again, in the description below, it is very simple to install then TensorFlow and Keras using DevTools. The description cannot be easier on these websites. Just go to tensorflow.rstudio.com/Keras. It'll show you how to import TensorFlow and Keras. Now for TensorFlow, there are two versions. There's of course the normal CPU version that will run on your computer, no problem. But if you have an NVIDIA graphics processing unit, a gaming card, you can use the GPU version. That is much faster than a CPU. It allows for parallel execution. TensorFlow can use those GPU cores, CUDA cores, so it's got to be an NVIDIA GPU, and it'll run a lot faster. Now if you're in a normal laptop, even if it does have an NVIDIA graphics card, and I'm recording on just such a laptop and it has quite a high-end graphics card in it, it's still not enough. When you get to very large data sets, specifically if you look at images as your data set to do some deep neural networks to learn from images, you are very quickly going to run out of the capacity, and specifically the memory capacity of that GPU, and that's just going to be very frustrating. So for the kind of things we're going to do in this course, and if you're starting off with deep learning, just install the normal CPU version. It's going to run slower, but it's still going to get the job done. If you're adventurous or you have got a monster desktop with two Titan X NVIDIA graphics GPUs in them, go ahead, install the GPU version, no problem. So that was a very short introduction to R. I think that's the basics that you require. It is a lot in one video to get used to. So perhaps pause, go through it again. These files are available, play with them. There is just one way to go about this though. Sit down and start playing. It is fun. It is a lot of fun, and there's a great sense of accomplishment when you get something done. So really, I just want you to do it. We're also going to write lines of code when we create our TensorFlow deep learning models. So you will have to write some lines of code, and as you write those lines of code in the future videos that I will make, you just pick it up along the way. So it really is fantastic and an easy and nice way to do it. This RStudio environment is fantastic. I'm going to stick with R for this introductory series on deep learning because it is such a nice environment. As you can see for yourself now, picking up the language is very easy. And then to write the same models in Python, once you can do it here in R, it's just a breeze. I mean, it is the smallest, tiniest little learning curve. So if you want to move over to Python, which is the natural language for TensorFlow, it's a no-brainer. It's very easy to do. And perhaps I'll make some videos just to show you how this works in Python as well. Stick to R for now. I mean, R is fantastic for normal data analysis, normal statistics. I use the term normal, but just for that workhorse and creating beautiful graphics, graphs, plots that you can put inside of your dissertations, inside of your publications. It's just a phenomenal environment, as is Python. I mean, Python, R, there's this debate, which one should you do? Do both. That's just the solution to the problem. Just learn how to do both. They are very similar. There's some quirks, specifically on the R side, that you've got to get used to. The Python side's actually much, much, much easier. So once again, if you start with R, that just makes Python a breeze. And but learn how to use both. That would always be my suggestion. It really is not a stretch. This is not difficult. Really not difficult to learn a computer programming language. So I hope I've got you excited. I hope you feel comfortable that you can start playing in R now. Go and enjoy yourself.